2010 question number 6. These are tough. Take your time, but they're not so tough that you can't do them. They just hurt your brain. Okay, function above is f. It has derivatives of all orders. Let the function g be described like this. Write the first 3 non-zero terms in the general term of the series for cosine of x about x equals 0. Use this to write the first 3 non-zero terms and the general term of the Taylor series for f about x equals 0. Good Lord. Okay. Cosine of x, we know the series for. Cosine of x is the evens. We start with 1. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Write the first 3 non-zero terms. There we go. And the general term. The general term. -1. Oh gosh, I'm trying to give myself space here. X to the 2n over 2n factorial n equals 0 to infinity. Okay, easy. Use this to write the first 3 non-zero terms and the general term for f. So that means I'm supposed to take my series of cosine, subtract 1 from it, and then divide everything by x squared. So f of x is subtract 1, that'll cancel out the 1, and divide everything by x squared. So I'm going to end up with -1 over 2 factorial, but just 2, plus, if I'm dividing by x squared, plus x squared over 4 factorial. They want how many terms? The first 3 non-zero terms. So let me get one other and see how this is going to flow. I know my next term would be x to the 6th. So now this is x to the 4th. And this would be 6 factorial. Okay, so there are my first 3 non-zero terms. And now the general term. So the general term is going to have an alternator. I'm going to have still x to the 2n, but now on the bottom, I'm going to have 2n plus 2 factorial. I think that will work. That'll bump my bottom 2 more than my power of my top. Let's see, if I start with n equaling 0, I'll still be in a good spot for the first term, and the second term I'll be good, and then this can be n plus 1 because I'm going to need my first term to be negative. Okay, there we go. That's a lot. That whole part is only worth 3 points. 1 point for the series for cosine, 1 point for the first 3 terms of f of x, and 1 point for the general term. Okay. Part B. Use the Taylor series for f found in Part A to determine whether f has a relative max, relative min, or neither at x equals 0. Give a reason for your answer. Wow. So if I want to know if something has a min or a max, I want to know if the first derivative is positive or negative, first of all, or equals 0. So let's see what happens. I don't know if it's positive or negative. Sorry, I want to know if my first derivative is 0 or not. Because the only way I'm going to have a max or a min, the first derivative will have to be 0. So my first derivative at 0, so how would I figure this out? So one way to figure it out is you could take the derivative of this whole thing and plug in 0. You can also think about what was the first derivative. If this is a Taylor series, the first derivative would have an x to the first with it. There is no x to the first, so the coefficient must have been 0. You might want to rewind and listen to that a couple of times, what I just said, but you have two ways of thinking about what the first derivative of f is. One is take the derivative of this series and realize that, oh, when I take the derivative, this will be gone. Everything else is going to have an x in it. So when I plug in 0 for the derivative, I'm going to get 0. Or you can think, well, wait, this is a Taylor series. My first derivative term would have an x to the first with it. I have no x to the first term, so the coefficient must be 0. So the first derivative is definitely 0. But I can't figure out, like if I tried to make a number line, like I did back in the day, and tried to figure out, did my derivative go from positive to negative or negative to positive to try to figure out if I have a max or a min? I'm not going to be able to do that with this. So I'm going to have to use something else. That something else is called the second derivative test. We learned about it this year. Do you remember it? I don't know. That's what makes studying for the AP test so hard, because there's so much coming together. I would not ask you to answer part B on a quick check, but that could be a question that shows up on the AP exam, which we will review for the whole month of April. But if you remember the second derivative test, it says, if my second derivative is positive and my first derivative is 0, that means I have a min, because that means the function must be concave up. So therefore, that derivative being 0 would happen at a min. And if my second derivative is negative, it means my function's concave down. So if my first derivative is 0, I must have a max. So if I look at my second derivative, can I figure out what the sign is of the second derivative in the same way I just thought about what was the sign of the first derivative? Well, the second derivative of f at 0, I could take this derivative twice, or I could also think, okay, the second derivative of f will be aligned with the x squared term. So the second derivative of f would have been here in front of the x squared term with a factorial underneath. Well, this is positive. So I know that my second derivative will be positive. So therefore, f is concave up. F prime equaling 0 means I have a min down there. All of that is 2 points. 1 point for telling that the first derivative must be 0. So at least you would get 1 point for that if that second derivative test is something that eluded you. Okay, back to Taylor. Part C, write the fifth degree Taylor polynomial for G. Okay, so to write the Taylor polynomial for G, we have to remember what G is. Because I'm going to need a lot of derivatives. I'm going to need to figure out what is G of 0, what's G prime of 0, G double prime, and so on. So I'm just going to write down here, G of x is 1 plus the integral from 0 to x of f of t dt. Let's write down all of our orders of G, our derivatives of G, and then we'll start evaluating them at 0. So there's G of x. So what's G prime of x? The derivative of 1 is 0, and then the derivative of the integral is just f of x. So now let's keep going. The second derivative of G is the first derivative of f. The third derivative of G is the second derivative of f. And we're going to have to go all the way to the fifth because we're going to want a fifth degree term. The fourth derivative of G is the third derivative of f. The fifth derivative of G is the fourth, derivative of f. Okay, so how do we go about finding that? Good question. let's see. So I guess I'm gonna start here. Let's evaluate this at x equals 0 and get a numeric value. So what is g of 0? Well, it's 1 plus the integral from 0 to 0, so that's going to be 0, so this is going to equal 1. What is g prime of x, or what is g prime of 0? That's the same as f of 0. So what is f of 0? Go up here. F of 0, whoops, here it is. F of 0 is negative 1/2, they tell us. Okay. G double prime of x is the same as f prime of x. So what is f prime of x? Let's go up here. What is the derivative, the first derivative of f? So the first derivative of f we already know is 0. But the second derivative, are we going to have to find the derivative? Or are we going to be able to take a shortcut? Sorry, I'm like thinking to myself. Wait, why am I doing it this way? Oh my gosh. Why am I not taking the integral of the series? That would be so much easier. Oh my gosh. Okay. I was just about to go through and find all of these derivatives, but what if instead, since I know, oops, I want a different color. Since I know that g of x is 1 plus the integral from 0 to x of f of t dt. And I know what f of t dt is, don't I? I know what f of x is. We know that the series for f of x was already found in part A. We know that the series for f of x isn't here. I think I erased it. Oh no, it's here. It's right here. The series for f of x is right here. We know that the series for f of x is this. So why don't I take the integral of that? Oh my God, that'd be so much easier. Okay. So we know that the series for f of x is negative 1 over 2 factorial plus x squared over 4 factorial minus x to the 4th over 6 factorial, and so on. Let's get one more. Oops. So why don't we find g of x this way? So why don't we take, since we know what f of x is, why don't we take the integral of both sides and get the integral for that and then add 1? So the integral is going to be negative 1/2 x plus x to the 3rd over 3 times 4 factorial minus x to the 5th over 5 times 6 factorial, and so on. So we know that g of x is 1 plus that integral, 1 plus, or in this case, plus negative 1/2 x plus x to the 3rd over 3 times 4 factorial. And what do they want? They want, write the 5th degree Taylor polynomial for g around x equals 0. Well, there it is. We just went one term too much. Wow. There's the 5th degree Taylor polynomial for g. That's crazy. That particular part of the problem is 2 points. But that's so much easier. Why would I want to go through all of these derivatives? That would have taken me forever to get all those derivatives. I do not want to do that. I should have built it. So when I guess that the lesson is, when I start seeing that I have to take a million derivatives, just like I did in the last problem, and I realized, oh wait, no, I don't want to take all those derivatives. I wanted to just substitute into a series I know. If you have to take a million derivatives, we're doing something wrong. We should be able to build it in a different way. That should be our clue to stop and see if we can build it a different way like I did here. Build it from something I already know. I knew the series already for f, so I can figure out what the integral of the series of f is, and then just add on 1. Whoa, so much easier. Okay, part D, the Taylor series for g evaluated at x equals 1 is an alternating series with individual terms that decrease in absolute value to 0. This is just basically setting me up for error and telling me that my error is going to be found by taking the next term. So use the third degree polynomial. So that means to find error, find the next term, find the value of the next term. That's all I have to do. They want to know what the error is at 1. So I'm plugging 1 into this term. So for part D, all I have to do is say 1 to the 5th over 5 times 6 factorial. And is that number smaller than 1 over 6 factorial? Yup, because 1 to the 5th is just 1, and this has more on the bottom, so this is smaller than that. That is all you have to say, is give the next term. Whew, that was a doozy.